What's poppin', dogs? Mr. Allen here. We are talking compound interest in this video here. We got Dr. Dre, Snoop Dogg, Eminem, and 50 Cent. We got the whole crew, man. And they are all investing, right? It's a wise decision. They got themselves 5.94 annual interest. They all decided to invest, you know, they're a crew here, $6,000 for 14 years. They're each going to invest in their own individual accounts. Dre has an account that will compound quarterly, Snoop's will compound monthly, Eminem's will compound daily, and 50 will compound continuously. So how much will be in each account after 14 years if no money is added? So like a great control situation to see the different effects of compounding, right, on this money here. So we need a couple formulas, right? So there's a formula for compounding daily, monthly, weekly, quarterly, whatever, and that is A of T equals P. Then we have 1 plus R over N raised to the NT. Now, what the heck does all that mean? Well, P is my principal, the amount of money we start with. R is my rate. N is the number of times we compound. And T is the time. Perhaps we should write that all down. So P, that is our principal. That's the starting money. Starting money. It's a little sloppy. Then we have ourselves R, that's the rate, as a decimal, right? So decimal. Then we have N, that's the number, not hashtag, number of times compounded. And then lastly, T is time. Cool. So there we go. That's our formula we're going to work with, okay? But then there's also the continuously one, which is interesting, right? It's a different one. That is a separate formula. And it is as follows. P, so A of T equals P times E raised to the N, to the RT. All right? And that E there, that E is a button on your calculator, okay? So if we were to actually, just do that right now, let me pull up my calculator. If I hit second natural log, you see how it's highlighted red right now on LN? That E pops up. We're going to use that in a little bit when it comes to Eminem's money, right? Okay, so there we go. So now we're all set. We can get each individual person here. So let's go with, in green, we'll do Dre. So this is going to be Dre here, Dr. Dre. Now he has A of T. Everybody's doing 6,000, right? Everybody's doing 6,000. So 6,000 is my P. Then we have 1 plus, everybody's got 5.94. That needs to be a decimal. So we're going to have 0.0594. That's my rate as a decimal. And then I have N, which is the number of times. His is quarterly, so it's going to be 4 times per year, right? So 4 times per year. Raised to the 4 times, and then we have 14 for the years. Okay, so what we do is we divide that rate by 4. So it gets equally spread out for those 4 times. But then we raise it to an extra 4 times per year. That's what the 4 is in the exponent. We're going to raise it 4 times per year, right, to that exponent, and multiplying that compound interest will happen 4 times throughout the year. But you don't get the 5.94% 4 times a year. You get a fourth of that, okay? So anyways, let's plug that in, right? Actually, you know what? Yeah, let's plug it in. Let's plug it in. Let's do it. Okay, so let me... I got to pull up my calculator. It's not up. It's a whole thing. It's a whole screencast thing, right? Well, we got 6,000 and then 1 plus. And you can type it in with like alpha x. You can do a fraction here if you'd like. You don't have to. You can just do straight up division. I'll show that in the next one. Oops, I missed something. 0.594, okay, divided by 4, parentheses, and then we have raised to the 4 times 14. We've got 13,697.93. Let's go to the nearest dollar here. Let's do that. 13,698. So about 13,698, okay? So that's the first one. That's Dre. Now let's take a look at, we'll go orange now for this one, for who's next up? Snoop. Snoop's is monthly. So everything's going to be the same here except that 4 is going to become a 12 because there's 12 months in the year. So for Snoop-a-loop, we've got A of T equals 6,000. Then we have 1 plus 0.0594 over 12, and then we have 12 times 14. See what that's going to be. So actually a cool thing you can do in the calculator here is if you don't want to retype all that stuff, you can arrow up, you can copy it down, and then I can just change this 4 to a 12, so 1, and then you can insert second delete, allows you to type in front of stuff without deleting stuff, right? Or you could just type 12 times 14 if you're like, oh no, I wrote over it, it's okay. And then over here, I've got 12. So it actually does help to just do the fraction in there because then I can type whatever I want if I have to do like multiples of these. Some tests, they'll ask you like 5 different questions on these. You're like, which one's the most? And then you can just keep on changing stuff in your calculator. So I'm gonna hit enter on that. And we do have a little bit more. We have 13,753.70. So if we go to the nearest dollar, it's gonna be 13,754. 13,754. Cool. Now, last one here for the compounding of, not continuously. We've got daily, right? I think it was daily for that last one. M&M's is daily. Okay, 50 is continuous. I think I said M&M earlier. So for M&M for compounding daily, M&M. You guys know why his name's M&M? Marshall Mathers, okay? So M and M, but he spelled it out because that's cool. All righty, we got A of T, fun fact, equals 6,000, and then we have 1 plus, same stuff, 0.0594, and then we have 365. 365 times 14. Lovely. So let's plug it all in. Just a lot of back and forth here with the calculator. I'm going to arrow up again, copy that bad boy down, and then if you wrote over this like 365, oh no, times 14, I just type it again, okay? No big deal. Down here though, 365, it allows me to type because I'm in the denominator of that fraction, which is super cool. I don't have to actually arrow out of it like I was doing there. You can just hit enter right after you do the 365. And again, we have a little bit more. So the more times we compound, it seems is the better. I wonder what continuously will do. Woo. 13,781 will be the rounded to the nearest dollar. 13,781. Cool. So more times compounded seems to be the better, yes. Now let's go with, let's see, we got, what color? Pink? Okay, we'll go pink here. So we have 50 cent. So his is the other formula, the continuously, right? The APERT, as we abbreviate it on the streets, the mathematical streets, that is. So E is just E. It's not some variable. It's a number, okay? It's a number, kind of like pi is a number. E is a number. It's a pretty dope number. And then we have raised to the RT. I almost said N again for some reason. So the rate goes up here now, 0.0594, and then we have 14 years, so times 14. I actually like the continuously one. It's a nice clean formula, right? I'm not like thinking about, oh, this, that, whatever, all these different numbers. So super easy to plug in. So we got 6,000 times second ln, right? E would be the inverse of natural log. Okay, we'll start learning about that later on. And in other ones, we start solving stuff, use E to undo natural log and vice versa. So they are inverses of each other. Log is base 10. That's why you see 10 to the x above it. X squared and the square root go with it. See how they think about these keys here? The second button goes with the inverse. On and off. Look at the off key. It is the second of on. That was a tangent, guys. My shirt says sometimes I go off on a tangent. It's on the back. Maybe I'll show you one day. Anyways, 0.0594. And then times 14. Ooh, man, that's really, really close to the daily, isn't it? It's only, just under $1 more. We'll round it, and it will be, in fact, $1 more. So we have 13,782 to the nearest dollar. But the more you compound, it seems is the better, right? And that continuously is like, it's almost like infinitely compounding. If you were to increase that number in this formula here indefinitely, you go like 1,000, 1,000,000, 1,000,000,000, whatever. Eventually, it would work out to being this base of E. This part in here would, and the exponent, it would all work out to that. It's a whole thing. It's a proof. I'm not going to get into that. But there we go. We have how much money will be in each account after those 14 years so we can handle any type of compounding situation. The amount of fun there was compounding. I'll show you the back of my shirt now. Hold up. There we go. There's the back of the shirt. Sometimes I go off on a tangent. You see? That was the mathematical joke right there. HHS math team, dogs. All right. That's it. Thank you for watching. You guys have a wonderful, fantastic day. See you later.